Hello, welcome to our first set of notes for semester 2. You should be writing these maybe on January 4th, 2021. We are going to be talking about sum of interior angles of polygons today, and the first one we're going to start with is the sum of an interior angle of a triangle. So some of the things we already know is that a triangle has 3 sides, and there is one triangle that's created within that triangle. We already know the sum of the interior angles of a triangle. Hopefully we remember that any triangle has a sum of 180 degrees. And then if you feel you can fill in any of these, go ahead and pause and do that on your own. Now a quadrilateral we know has 4 sides, and if I could draw a triangle through connecting the vertices, I can draw 2 triangles. I can't draw another one without crossing the line, so really there's only 2 triangles here. And since I know one triangle is 180 and I have 2, I can either add that or multiply by 2, getting that the sum of the quadrilateral is going to be 160 degrees. So a pentagon here, I have 5 sides, and drawing diagonals that do not intersect, I create 3 triangles in here. So I can either do 180 times 3 or add another 180. I'm going to get 540. So here I have a hexagon. A hexagon has 6 sides, creates 1, 2, 3, 4 triangles. So I can either do 180 times 4 or add another 180 for 720 degrees. Heptagon is going to be 7 sides. And if I look at my pattern, what's going on, I have 1, 2, 3, 4, 7 sides is going to create 5 triangles. 8 sides will create 6 triangles, 9 sides is going to create 7 triangles, and a decagon will be 10 sides is going to create 8 triangles. So that pattern is going to continue. So we have 720, go ahead and add 180 each time or multiply that number by 180. I would get 900 degrees here, 1080 degrees here, 1,260 degrees here, 1,440 degrees here. So now if we look at this information, and instead of creating it every single time, we can create a formula that would work in every situation. If n represents the number of sides, so this right here is my n, of the polygon, then the sum of the interior angles is going to be what? What do I do with this number to get this answer? So if this is my n, what do I do to this? Well, first, what happens in each of these cases? Can you see this relationship? These numbers have a difference of 2. So if I take n, my number of sides, and I subtract 2, and I get this number, then I'm going to multiply it by 180 degrees. This is my formula for the sum of the interior angles of any polygon. Now if I want the interior angle of a regular polygon, remember a regular polygon has all sides are congruent. So that means I'm going to do this, and I know that they all add up to this. Well, if I wanted one interior angle, I'm going to write one angle of a regular here. Well, with a triangle, if it's a regular polygon, what do? I take that number and I'm going to divide it by 3. So I would get 60. If the quadrilateral was regular and all the sides were the same and all the angles were the same, I would take the 360, divide it by 4. And I'm going to get 90 degrees. I would take the 540, divide it by 5, and what am I going to get there? 108. So I can take each number, divide it by that, 720, divide by 6, I'm going to get 120. This one does not work out evenly. But that's what I have to do. So if I'm going to write this formula down here, I'm still going to use, so I'm trying to make sure I'm on the paper. I'm going to take this formula, I'm still going to use the n minus 2 times 180, but now if I want to find a single one, I'm going to divide this by that n. And that's going to give me one interior angle of any polygon. Okay, I'm going to pause and go to the next page. Before I go to the next page, I decided to fill out the rest of these on this side. 720 divided by 6. 900 doesn't divide evenly by 7. 1080 divided by 8 is 135 for one angle of a regular polygon, or octagon in that case. 1260 divided by 9 is going to be 140 degrees. 1440 divided by 10 will be 144 for every angle of a decagon if it's a regular decagon. Regular, again, meaning all sides are the same and all angles are the same. Okay, we're going to go to the next page. We want to find the sum of the interior angles of a 15-gon. So again, I don't know the name of a 15-gon, but I do know my formula for this, and I am going to take n minus 2 times 180. So in this case, my n is 15. 15 minus 2 times 180. 15 minus 2 is 13 times 180. I'm going to use my calculator for that. And we get 2,340 degrees. Okay, find the sum of the interior angles of a 21-gon. I'm going to start with 21 minus 2 times 180. 21 minus 2, I get 19 times 180. Go ahead and multiply that together. You should get 3,420 degrees. So again, quiz yourself, come back and check after you pause, work them out. The measure of each, okay, so these are words that we want to pay attention to. Find the sum of the interior angles. This one says find the measure of each interior angle of a regular. Each interior angle of a regular. That makes it a little bit different. That means you want to find one of them. So a pentagon again, 5 minus 2 times 180. Then I'm going to divide it by the number of sides, which in this case is 5. We already did this on the last page, but again, 5 minus 2 is 3 times 180 divided by 5. 3 times 180, I get 540. Divided by 5, and I end up with 108 degrees. What is the measure of each interior angle of a regular 18-gon? So this one may be a little trickier. 18 minus 2 times 180 divide by 18. 18 minus 2 is going to be 16 times 180 divided by 18. Now again, you can use your calculator for this, but this one's kind of easier by hand. 18 goes into 180 10 times. 10 times 16 is going to be 160. So always kind of look at that. I know you guys have calculators at your fingertips, but if there are ever things that you want to become familiar with some of these numbers and be able to work those out. Now, we're going to move on to exterior angles. If we want the exterior angle sum, exterior angles are always supplementary to their adjacent interior angle. On the polygons below, find the measure of each exterior angle along with the sum of all exterior angles. So, it's a linear pair, which means you're going to take 180 minus 61, and we get 119 here. Here, I'm going to take 180 minus 79, and I get 101 here. Here, 180 minus 40, and I get 140 here. So those are each interior angle. Now what I want to do is I want to add those together. Add these three numbers together, 119, 101, and 140. 9, 10, 4, 5, 6, we get 360 degrees for the sum of the exteriors. Go ahead and do that over here, see what you get. When I subtract these from 180 and I get the exterior angle, I got 109, I got 56, 104, and 91. Go ahead and add those together. When I add these four together, I end up getting 360 degrees. Okay, I'm going to pause. I'm going to do the next two and come back and check them in just a minute. So pause your screen, work them out on your own, come back and check. Okay, so here we got our outside angles were 76, 82, 59, 93, and 50. So hopefully you got the same things. Remember that each of these are linear pairs. They have to add up to 180. Once I do that, now I'm going to add all of those exterior angles together, and I got 360 again. Over here, these are my exterior angles, 63, 65, 51, 56, 68, and 57. So again, add all of your exterior angles together. What do you think you're going to get? So again, we get 360. So what's the conclusion we can make? I can say that the sum of the exterior angles of any polygon is 360 degrees. So now down here it's going to say, well, if we know the sum of the exterior angles is always going to be 360, what if I want to find the measure of each exterior angle of a regular? Each exterior angle of a regular. Each, if the exterior angle of a regular polygon is 12, how many sides? Oh, this is going to work backwards, so we're going to have to do that. Now, if we know they all are 360 and we want to find one of them and they've all got to be the same, I'm going to take 360 and divide it by, in this case, it's a hexagon. How many sides is a hexagon? Do you know? Hexagon, six sides. So 360 divided by 6, we're going to get 60 degrees for each of them. Now, what is the measure of each exterior angle if it's a regular 24gon? I'm going to take 360, divide by 24. Now again, by hand you can do this, you can use your calculator, but these are both divisible by 12. 12 is going to go into this 30 times, 12 is going to go into this twice, 30 divided by 2 is going to give me 15 degrees. So there we go. Now, if we want to find each angle of a regular polygon, and I know it's 12, how many sides does that polygon have? So now my missing value is the number here. So I'm going to take the 360. We have to divide it by some number, but I know the measure is going to be 12. Can we solve that? If I cross multiply and divide, remember you cross multiply, you end up with 12x equals 360. Divide both sides here by 12. X equals 30. 12 goes into 36 3 times, so 30. Go ahead and work this one out. Come back and check it. If the exterior angle of a regular polygon measures 40, so we have 360 degrees. We don't know how many sides, but we know it's going to be equal to 40. So in this case, we're going to have 40x equals 360. Divide by 40, I get x equals, well, the 10 cancels out, 4 goes in there, 9. There we go. We have 9 sides of that polygon to get each exterior angle to be 40. Okay, I'm going to pause and go to the next page. I'll be right back. Hi, so our next page of notes actually has this nice little summary of the formulas that we just learned. And if you remember last semester, when we came upon one of these pages, I've always told you to maybe put a paper underneath it so you don't mark other pages. and you can highlight the edge of it, and then it makes it easier for you to flip back and find it. You can do that, or you can put a sticky note there, but this might be a page you want to refer back to because it has these special formulas. So I'm going to highlight the edge right here. That way in my notebook I can flip back to it pretty quickly. Okay, so we have these new formulas here. You don't have to, but you may want to number them if you want to refer back to them for some reason. We have, I'm not going to number them. Anyway, some of the interior angles of a polygon. So if you remember any of these without looking, pause, go ahead and fill them in. Some of the interior angles of a polygon, remember it's the number of sides that we have, minus 2 multiplied by 180. Now, if I want to find the interior angle of a regular, so still interior, I'm going to take the m minus 2 times 180. Now I take that, though, and I divide it by the number of sides to figure out what one of them is. Some of the exterior angles of any polygon, every time, all the time, no matter what, 360 degrees. Now, if I want to find exterior angle of a single angle of a regular, I'm going to take 360 and divide by n. Now, if I want the number of sides of a regular polygon, I set up the equation each time. I would do 360 over n equals the angle, and I would work that backwards, that equation. So we're going to do a few of these, not all of them, but go through. Let's go ahead and do one. What is the sum of the measures of the interior angles of a pentagon? Pentagon, hopefully we remember, is 5. So I'm going to take 5 minus 2. I'm going to multiply it by 180. We already did this one. Hopefully have it memorized. 3 times 180, and we get 540 degrees. Now there are going to be some that after a couple days, you're just going to know them. You should have them kind of in your memory because we do them so frequently. Let's do one of these. The sum of the measure of the interior angles of a 27 gon, 27 minus 2. What is the measure of each interior angle of a 20 gon? Let's do that one. We'll do 20 minus 2 times 180. Then I'm going to divide it by 20. Well, 20 minus 2 gives me an 18 times 180 divided by 20. I can divide by 10. 2 goes into 18 9 times. So it's going to be 18 times 9, and I should get 162. There we go. All right, let's go ahead and find the angles of a hexagon, measure, what is the measure of the 6th angle? So I have a hexagon. What I would do is I would take all of these angles here, I'm going to add them together. Okay, so we're going to add together 119 plus 129 plus 104, and add together 139 and 95. Add these all together, 18, 22, 2, 3, 4, 5, 1, 2, 3, 52, 14, 13. So I get 352 plus 234, 6, 8, 586. So it's a hexagon. A hexagon is 6 minus 2 times 180. 4 times 180, and I get 720 degrees. So the entire hexagon should be 720 degrees. The angles that I know add up to 586 degrees. So what do I do to figure out what the measure of the last angle is going to be? I'm going to take that 720, and I'm going to subtract the 586. I end up with 134 degrees. We're going to skip some of the interior angles of a polygon. Oh, this one actually is kind of interesting. Sum of the interior angles of a polygon is 1620. So if I have n minus 2 times 180 equals 1620. I need to solve this for n. The sum of the interior angles of a polygon is 1620. How many sides does it have? I'm going to backwards distribute this. I get 180n. 180 times 2 is 360 equals 1620. I'm going to add that 360 over here. 1620 plus 360, I end up with 1980. 180n equals 1980. Divide by 180. That cancels. Divide by 180. We end up with the number of sides here will be 11. Their work was a little bit less. So I'm going to do what they did. Mine ended up being bigger numbers. They start with the same equation, n minus 2 times 180 equals 1620. If you see this right away, you could divide by 180, and you would get n minus 2 equals 9. And then add that 2 over, you would get n equals 11. Either one is perfectly fine. The numbers here end up being a little bit bigger. If you're going to use a calculator, this is probably easier. The sum of the interior angles of a polygon is 3960. How many sides does the polygon have? Go ahead and pause and see if you can work this one out. This is my work. I ended up getting 24 sides. So go ahead and check through that. Again, you could have done it like this and divided by the 180 to begin with. Either way, you should get the same answer. What is the sum of the measure of the exterior angles of a nonagon? Well, the exterior angles of any polygon ever, it doesn't matter how many sides it has, every single time, no matter what, 360 degrees. What is the measure of each? So those are keywords you want to make sure you're paying attention to. Exterior angle of a regular 20gon. Well, we know it's going to be 360 for all of them, and if there's 20 angles, you divide that by 20. Remember, always if they end in zeros, you can divide that 10 out. 2 goes into 16, 18 times. So this is going to be 18 sides. Or 18 angles, sorry. 18 degrees. It was 20 sides, 18 degrees. There we go. There's a few more problems on the next page that I want to go over. Again, not too many. If the exterior angle of a regular polygon measures 9 degrees, how many sides does the polygon have? So 360 divided by the number of sides equals 9, which means I'm going to get 9n equals 360. If I cross multiply, divide by n, or divide by 9, we are going to get n equals 40 sides. If the interior angle of a regular polygon measures 180, how many sides does this have? So this one's a little bit trickier. This said exterior angle, this one says interior, which means it's 180. Now remember, if the interior is 108, what would be the exterior angle? Subtract from 180, and we should get 72. So this one's going to be 360, divide by the number of sides, and the exterior angle, if the interior is 108, the exterior is 72. I end up with 72n equals 360, divide by 72. I get the number of sides to be equal to 5. There we go. Find the value of x. Here we're going to do x over here. How many sides do we have? 1, 2, I usually mark it. 1, 2, 3, 4, 5, 6, 7. So I know 7 minus 2 times 180. 5 times 180. I know that my sides should add up to 900 degrees. Well, so now I'm going to add all the numbers I know. I'm going to add 136, 140, 148. This one right here, this one's 90, 150, 142. I add those together and I get a sum of 806. So now I'm going to take 900 minus 806. We end up with 94 degrees. I'm missing an angle there. I'm going to pause and be right back. We're just going to do like one or two more. I'll go ahead and solve 14 here for us. This has 1, 2, 3, 4, 5, 6 sides. Go ahead and see if you can set this up and solve it. I'm going to pause and do the work, and then I'll show you my answers in just a minute. Here's my initial setup. I know 6 minus 2 times 180 is going to be 720, or hopefully I have that memorized at some point. I'm going to add all 6 of the angles. 1, 2, 3, 4, 5, 6 angles equals 720. Combining like terms, I ended up with 26x plus 278. Check my work, make sure that we did that correctly. Go ahead and finish solving. Should end up here with x equals 17. So good job, those of you guys who worked that one out. Let's do one more. Let's go ahead and do the last one here. 17 solve for x. These are exterior angles, which means all of them have to add up to 360. Go ahead and set it up and come back and check. This last one I kind of did a little bit differently. Up here I wrote them all out in a line, and then you have to go through and combine your like terms. Here, if I write them vertically here, I have all my numbers lined up, constant numbers. I have all of my variable coefficient numbers here, so I can add up my like terms right away. I got 29x plus 12, set that equal to 360, and we end up getting x equals 12. All it wants us to do is solve for x, so we are done. Okay, that concludes our first set of notes for the new year. Hope you had a fabulous new year. Have a fabulous day. I'll see you next time.